Welcome back to another session in the TAE certification series. Today, get ready for some practice questions for chapter 7 to test that what we have learned so far. So let's get started. Okay, so let's start with question number 1. Which of the following is true about the components of a TAS? And the options we have are option A, they are not important for reliable performance. Option B, they include only executable components. C, they include functional libraries and supporting data and configuration files. And option D, they are not affected by the configuration process. Okay, so at this point, I would highly recommend that you pause the video and take a guess at the right answer before we discuss it together. So I hope that you have already guessed the right answer, and now let's see what's the correct one. So the correct option is option C. They include functional libraries and supporting data and configuration files. Okay, this option is correct because the components of a TAS, they include the executable components, corresponding functional libraries, and supporting data and configuration files. So these components need to be accounted for to ensure reliable and repeatable performance. Okay, now let's have a look at the other options which are incorrect. So the first one is they are not important for reliable performance. So this one is incorrect because we have just seen that the components of a TS, they are actually important for reliable performance. Option B, they include only executable components. So this one is also incorrect because the components of a TAS include not only executable components but also the corresponding functional libraries and also the supporting data and configuration files. And then we have option D, they are not affected by the configuration process. This one is also incorrect because the configuration process, it may range from the use of automated installation scripts to manually placing files in corresponding folders. So the components of a TAS, it may also have some service packs or some maybe optional or required add-ons to ensure compatibility with any given SUT environment. Question number 2. In a testing scenario where known passing test cases fail and test cases pass despite being expected to fail, what actions are crucial for troubleshooting and identification? And the options we have are option A, verifying log files, performance metrics, and automated setup or tear down processes. Option B, executing tests from different test types and levels. Option C, identifying the test framework's level of performance. And option D, checking the correctness of the test scripts generation. And the correct answer is option A, verifying log files, performance metrics, and automated setup tear down processes. Okay, now let's have a look at this one. Okay, so in a testing scenario where known passing test cases fail and test cases pass despite being expected to fail, it is crucial to verify the correct generation of log files, performance metrics, and also automated setup tear down processes. Now, the log files and performance metrics, they provide insights into the behavior of the SUT, system under test, and it helps identify potential issues or problems. Now, coming over to the automated setup or tear down processes, they ensure that the test environment is consistent and repeatable, which is very important for reliable and repeatable performance. So this option, option A, is the correct answer. Okay, now let's have a look at the remaining ones which are incorrect. B, this one is incorrect because executing tests from different test types and levels, they don't help identify the cause of known passing test cases failing or test cases passing despite being expected to fail. Now, this one can be quite confusing because this can actually assist in exploring different angles and scenarios, but it will not directly help to identify the cause. So this one can be a little bit tricky. Then moving on to option C, identifying the test framework's level of performance. This one is incorrect because identifying the test framework's level of performance, it involves evaluating the performance and efficiency of the testing framework, but it does not help identify the cause stated over here. Then option D, checking the correctness of the test scripts generation. Okay, this also does not help identify that why the known passing test cases fail or expected failing cases pass. So hence this one is also an incorrect option. Question number 3. What does checking the test suite mainly involve in terms of ensuring completeness and accuracy? And the options are A, verifying the framework and SUT versions, B, assessing the execution time of test cases, C, reviewing the test cases for expected results and presence of test data, and D, analyzing the code coverage of the test suite. And the correct answer is C, reviewing the test cases for expected results and presence of test data. Okay, so this one is correct because this helps to identify any missing or incorrect test cases, and it ensures that the test suite covers all the requirements of the SUT. Okay, now let's have a look at the other incorrect options. Option A, verifying the framework and SUT versions. So this one is incorrect because verifying the framework and SUT versions, it does not mainly focus on checking the completeness and accuracy of the test suite. Then we have option B, assessing the execution time of test cases. This one is incorrect because it is more related to performance measurement and efficiency rather than the completeness and accuracy of the test suite. Then moving on to D, this one is incorrect because checking code coverage involves evaluating how much of the software code is tested by the test cases. It is important for assessing testing effectiveness in covering code, but it doesn't directly ensure that the test suite is complete and accurate. Question number 4. In a software development project, a new update to the test automation solution has introduced a feature allowing parallel execution of test cases for improved efficiency. Why is it crucial to closely monitor and verify the functionality of this newly introduced parallel execution feature within the test automation solution? So basically, this question is asking that why it is important to keep a close watch and check that how well the new ability to run multiple tests at the same time, which is referred as parallel execution over here, in the test automation solution is working. Okay, so now let's have a look at the options. Option A, to assess the overall performance of the software project. Option B, to expedite the test execution process. Option C, to ensure the accurate and reliable operation of the new feature. And option D, to verify compliance with industry standards. And the correct answer is option C, to ensure the accurate and reliable operation of the new feature. Okay, so parallel execution of test cases can improve efficiency, but it can also introduce new issues or problems that need to be identified and resolved. So by closely monitoring and verifying the functionality of the new feature, we can make sure that it operates as expected and it does not negatively impact the quality of the software project. So this one is the correct answer. Let's have a look at the other incorrect options. Option A, monitoring the parallel execution feature, it might contribute to overall performance, but the primary focus over here is on the functionality of the new feature itself, not the broader performance of the entire software project. So that's why this one is an incorrect option. Option B, to expedite the test execution process. Okay, so parallel execution, it aims to improve efficiency by parallelly running the test cases, but the question over here is about monitoring and verifying this new feature functionality, not only focusing on the speed of test execution. So that's why this one is incorrect as well. Then we have option D, to verify compliance with industry standards. So this option does not directly relate to the need to monitor the parallel execution feature. So compliance with industry standards is important, but it might involve broader aspects of software development, not specifically tied to monitoring the functionality of newly introduced features within the test automation solution. So that's why this one is also incorrect. And the last question, question number 5, is what actions are recommended to identify the root cause of intermittent failures in testing according to the scenario? And the options are: rely solely on the test analyst expertise for diagnosis. B, run additional test cases to confirm the intermittent failures. Option C, analyze log files of the test case, framework, and system under test. Or D, proceed with debugging without log file analysis. And the correct answer is C, analyze log files of the test case, framework, and system under test. Okay, so this one, so analyzing log files of the test case, framework, and SUT, it is a recommended practice to identify detailed information about system behavior, or if there is any errors and exceptions which are encountered during execution. The log files, they often contain quite important technical insights that helps in understanding intermittent failures and also identifying their root cause. So this one is the correct answer. Option A, rely solely on the test analyst expertise for diagnosis. So while a test analyst expertise is valuable, but relying solely on human expertise might overlook important technical details which are captured in log files. So intermittent failures, they often have complex technical causes that might not be immediately visible without detailed log analysis. So that's why this one is incorrect. Option B, run additional test cases to confirm the intermittent failures. Running more test cases might help in understanding the consistency of failures, but it might not directly pinpoint to the root cause of intermittent failures. It could consume additional time and resources without addressing the core issue, which can be captured in the log files. Then we have option D, proceed with debugging without log file analysis. Debugging is a very important step in troubleshooting, but proceeding without analyzing log files can actually lengthen the diagnostic process. So the log files provides a wealth of information which helps in targeted debugging and which allows more efficient resolution of intermittent failures. I hope that these practice questions have been helpful for you. In the next session, we will start the last chapter, which is chapter number 8. Till then, take care and happy testing.